There we go. Hi, everyone. Today, I am going to talk to you about some cool ways you can use static type checking in your front-end JavaScript project. This is my first time in Eastern Europe. I've come all the way from Oakland, California, so thank you all for having me. A little bit about me first. I work for Stripe. As Bruce says, we are a payments processor thingy for websites. We're based in San Francisco, California. And for the past year, I have worked on the team that builds our main client-side libraries. So this is Stripe.js and Stripe Checkout. If you've ever used Stripe before, which I don't know if you have because we're not actually available in Eastern Europe, you may have encountered these libraries. So these are hosted JavaScript libraries that each power thousands of transactions a minute across thousands of our users' websites. And I was initially going to talk to you guys about type theory. So some types, type variants, type systems, math, strong typing, weak typing, etc. But that is kind of boring, and I threw that whole talk away about a week ago because it's easier to learn that stuff in class or on Wikipedia. And I thought this would be more interesting because you don't actually need to know type theory or know anything academic about it in order to leverage static type systems in your JavaScript. Instead, I want to share with you 3 different ways that we use Flow, which is a static type checker for JavaScript, in Stripe.js. So how many of you have used Flow, TypeScript, any statically typed language before? That's a good amount. There's nothing particularly unique or novel about the methods I'm about to show you. They're not really worthy of like a BuzzFeed listicle or anything. But they're also not explicitly called out in Flow's documentation, so it might take a few iterations to get to these ways of doing things. And I also think these 3 things I'm going to share with you in particular really show off some of the power of using a strong static type checker like Flow for your front-end JavaScript project. To understand a bit more about why we at Stripe need this tool, I'll first give a bit of context on what Stripe.js actually does. From our user's perspective, Stripe.js is an evergreen third-party library that they directly load onto the page from Stripe servers. The script then mounts like a bajillion iframes on your page and provides a bunch of pre-built UI elements and tokenization functions for you to use to collect payment information. So with this in mind, some of our goals as the engineers behind Stripe.js are to, number 1, provide a great developer experience for our users. Number 2, have limited runtime overhead and bundle size because we are in the critical checkout flow for our users. And number 3, to support all of the browsers. Our users are often using very, very old phones or IE9 or Mobile Safari 6, and these are all a bit nasty to deal with. So the methods I'll show you of using Flow actually all contribute to these 3 goals that we have in building Stripe.js. The first one is exhaustiveness checking. And I'll go more into why I call it not so exhausting exhaustiveness checking in a bit. One of the cool benefits to using a static type system that you might read about in blogs is that these systems force you to exhaustively check the type of the terms that you're using before they allow you to call certain type-specific operations for them. For example, Flow will never allow you to add 2 terms unless it is sure that they are both numbers. So here's a very toy problem that I'll walk you through to kind of get what exhaustiveness checking actually means. So say we have a function that takes user input and it capitalizes it. When reading this code, we kind of have to assume that the user is doing a type check outside of this function because as a code reviewer or someone looking at this code, I can't actually tell that we're doing any invalid input handling in the code itself. And of course, when the user inevitably misuses that function, they get this pretty nasty error that we're all very familiar with. Type error cannot read car of undefined. So this is not great because first of all, you're getting a runtime error that is exposing the implementation details of your function. But also, you're kind of losing your user's trust here a little bit because they now realize that you didn't think that they would make that mistake. And that's not really what a polished third-party library should do. So here's where Flow can help. Flow has a special type called mixed that acts as a supertype of all types in the type system. This means that you can cast any type to mixed, and it will be a safe cast. What this also means is that you must then refine any term that is mixed before Flow will allow you to use it. Here's our first attempt to write the same function using Flow, using the mixed type. We first type the value as mixed, and you'll see the mix propagate or flow through the code in orange. And we'll also state that the return value of our function is a string, because we're returning a capitalized string. And as written, Flow will not allow this to build, and this might be obvious to some of you. And here's why. So this is actually in my text editor. Flow shows me two errors. First one is I cannot call carat on mixed, and the second one is that I cannot call slice on mixed. That's pretty neat, right? Let's try writing it again. This time, I first check if the type of value is a string. And then within the body of this if statement, Flow now knows, because I've done this check, that the mixed, the orange value, is now a string, which is our blue value. And otherwise, I will throw a nice user-facing error about only being able to capitalize strings. And of course, when the user runs into this issue, they get a nice error. Sorry, we only capitalize strings here. And the user not only feels better because we've anticipated their error, but we're also now not leaking any implementation details of the function to our user. As an aside, this sort of nice developer experience is something that we heavily strive for at Stripe. We call this a pit of success. Specifically with our APIs, we try our best to create this pit of success for our users and try to anticipate the sort of confusions and errors that they may be running into. And this is especially important in JavaScript, which is a really weakly typed language, as you saw from Claudia's talk earlier. Exhaustiveness checks like the one that I just showed you for our capitalization functions are a especially useful tool for us in creating this pit of success. Flow forces us to exhaustively check all the options from our user-facing API, which lets us build type-safe and developer-friendly user interfaces. Now, let's talk about how we can expand these checks beyond the toy example of capitalization. Here's an example of a Stripe.js interface you might actually use if you're using Stripe Elements, but you guys probably can't because you're in Eastern Europe. We document it saying that you need to pass us a string, which is the element type, and an options object. But in reality, users can pass us anything because we're a third-party library. They can pass us undefined, numbers, whatever. And as you can see here, or you can't see because there's too many, the list of options that our individual UI elements in Stripe.js supports won't even fit on the slide. We have a lot of different options. And when we're writing the code that backs this API, of course, this might look familiar to you, that we're doing exactly what we did with the capitalization function. We're typing the inputs as mixed. But now, as we start to write the code, we'll soon realize that if we were to refine every single option that we support, which is on the left, we would end up with a lot of bundle bloat because we're writing all these if statements, we're writing a else that then throws an error. So how do we dry out this bunch of if statements and exception throwing code in a way that won't bloat the bundle and will cause our developers less toil? Well, we define what we call a type extractor. A type extractor extracts the actual type from an unknown mixed type. In Flow, we can define an extractor as a type constructor. And if you're coming from Java or any other statically typed language, this might look familiar to you. A type constructor is really just a higher order type that creates a new type. It's like a higher order function that returns another function, except this is only available at build time. So the extractor type constructor takes in a type parameter t and returns a function type, saying that this is a type for a function that takes a mixed value and returns a t, which can be anything. And that was a bit abstract, so let's go into how you would actually write one of these. Here is a type extractor for a string. Here you can see that we type this extractor as extractor of string. And from the previous slide, we now know that extractor of string is a function that takes a mixed and returns a string. And if you gloss over the function body, it's really just what we did in our capitalization function. We first check type of, and then Flow knows exactly what the type of that mixed type is, and otherwise we throw a nice error. So the great thing about this is that going forward, if you put a mixed value through this function, Flow now knows exactly what type it is when it comes out, and you'll be able to use that type going forward. Here is another one, basically exactly the same, except we're doing it for booleans instead of strings. So we do a type of check for boolean, call it bool, basically the same. And as before, remember, extractor of Boolean is a function that takes in mixed and returns a Boolean. So here is a more advanced example. This might take a bit longer to read, and especially if you're not familiar with Flow, but it's worth it to kind of see the power that Flow gives you. So this is a higher order function that takes in an extractor function and returns a new extractor function that extracts arrays of t. We call this higher order function on the string extractor that we defined before, and now we get an extractor of the type extractor of array of string. And this is really awesome. You can compose these as much as you'd like. Now, using the extractor functions we just defined, we can make our exhaustiveness checks a lot less exhausting by creating a data structure that maps each key in our documented options to the proper type check. At this point, you probably realize that we're missing something. Sure, each of these functions is an extractor, but the object itself is not an extractor. If we were to write a generic function that takes an extractor and validates the value, then we couldn't pass this object through it, right? So how do we tell Flow what the result of processing this object is? Well, Flow specifically has a powerful utility called objmap that comes to rescue here. And if you're using TypeScript, there's a similar utility that exists there. Objmap is a higher order type that says, take the values of an object of type O and use the build time function f, which you will define, to map the type of the values of O to a new type. So that's a lot of words. So here's our f function. It's called extractor to value. It takes an extractor and it says, I'm going to change this extractor to the type t, because the values in our options type object that we defined before were extractor functions. We can now define a function called combine types that takes a mapping of string to extractor, which is our options, and itself returns an extractor of an objmap that uses the extractor to value type to extract the types of each value in the input object. So now Flow knows all of the values in our resulting object. And now we're left with an even more powerful composite extractor that we can leverage for our options validator. So for example, in Stripe.js, we have this fonts option that is an array of a structured object. And with these extractors, we can now preserve the type safety of that entire array. So objmap, pretty complicated to use, but it helps you make exhaustiveness checks less exhausting. And this is really powerful because you only have to write that code in the previous slides once. You define your extractor once, you define your combine type combinator once, and everyone else now, when they're adding new options, just has to use those to validate their new options. So it's essentially free from a bundle size perspective when you're adding new features. Now there's a few rough edges with these tools that you might run into when you try to apply this to your own code base, so I'm happy to talk about that after. That was a lot of code. Let's look at this cat drawing for a bit while we transition to our next section. The second thing I wanted to talk about is typecasting across lossy interfaces. Let's unpack this a bit. We only allow safe typing to safe casting. Flow doesn't actually have this in their docs, but it is a true statement about Flow. Flow and strongly typed languages in general only allow you to safely cast terms. What this means is that you can only cast a typed term to a supertype of that term. That is a safe cast because as a supertype, it necessarily contains the type that you are casting from. To go back to mixed that we used earlier, remember that mixed is actually the supertype of all types because it's an unknown type. It includes all the types that Flow could possibly think of, and that's why you have to refine it down. So it's always safe to cast to mixed because it is a supertype of all types in the system. Arguments to functions are also terms, so when you are actually passing an argument through a function, you are actually casting that value. So a function that takes mixed will take string, will take number, all of this is fine, because within the function, it will cast the string or number type to mixed. Similarly, if you have a function that types its return value, casting to mixed is also fine. In this case, we are calling this function on two strings, but the return value of this function is mixed, and that's a safe cast, so when you call the function, the resulting value is going to be a mixed type. However, something like this would not be OK because it's not a safe cast. String is a subtype of mixed, and thus you cannot say that I'm returning a string from a function that has taken mixed and is directly returning it. And remember from part 1 that we will actually need to refine the mixed type in order for something like this to be possible. However, Flow also has a super special Snowflake type called any. And any is the subtype and the supertype of all other types, and that doesn't really make sense in a strongly typed system. This is problematic, and the only reason it actually exists is to help people convert their existing JavaScript code base to Flow. In this case, you might need some more flexibility, and any gives you that flexibility. In fact, Flow's docs say to never use any. This might be a review for some of you who already know Flow, but let's briefly go over why any is so dangerous. Let's say we have 2 terms, one of them called anything, which is declared as an any type. We can literally set anything to any value. The other term is called a number, and it is typed as a number. So thus, we should only be able to set numbers to a number. Of course, that means we can set anything to a number, because any is a supertype of a number. But when it becomes problematic is that you can also set a number to anything, because any is a subtype of number. This is really bad because Flow still thinks a number is a number and will thus allow numeric operations on that term, and you'll get a runtime error. So what now? We shouldn't use any, right? Never use it, and we won't ever have this problem. Well, in Stripe.js, we actually leverage this sort of unsafe casting in order to type some of our more nasty DOM interfaces. So remember at the beginning, I kind of told you that we work with a lot of iframes. A lot of iframes. And they all have to talk to each other. This way we can do cool things like autofill card details across iframes. Payments are super fun, I promise. We use the post message API to communicate between these iframes. Notice that when post messaging on one side, Flow knows the exact type of the message that we're sending. We've defined it in Stripe.js as something called cross-frame message, and in our code on the right side, this is actually how we've defined cross-frame message. It is a union of all the types of all possible messages that can go between frames, and we send a ton of messages. Because it is a union of all these types, that also means that it's a super type of each specific message type. We can also call this type of union a tagged disjoint union. This is a union in which no one part of the union can be confused for another member of the union. So let's define a toy version of cross-frame message and call it mini cross-frame message, just so we can kind of see why this is important to us. We achieve a tagged disjoint union by maintaining a single key with a unique value for each type of message. In our case, we've named that key action, but you can name it anything. Or don't name it anything. This way, when we're writing our code, if we refine based on the value of action, Flow knows exactly what type the message is within each block. This is similar to our type of check for string. Flow now knows within each of these case statements, also there's a syntax error there, I'm sorry, it knows exactly the type. So as you can see, tag disjoint unions can really be useful in general to help with type refinement. Back to post message. At the time of post message, we know that the message is a mini cross-frame message. However, on the other end, we receive post messages via an event listener on window. Understandably, across the event boundary, Flow probably doesn't know what the type of our message is anymore, because we've lost it when we've gone through the event emitter. And sure enough, if we look into Flow and we see how message event is typed within Flow, we can see that the message data is appropriately typed as mixed. This is good on Flow's part to type it as mixed because it is unknown and we should refine it. But this means at this point we've lost a nice type of our message, and now if we need to handle our cross-frame message, we have to refine it all over again. And additionally, this is a trusted same origin interface that we control both sides of. We send the post message, we receive the post message, so it seems really silly to add runtime extraction and build overhead just to get our nice type back again. So this is not a great situation, but we go ahead and define our own helpers for post message and parse post message. We then lint away the possibility of accessing post message directly on window, and we force all cross-frame messaging through these two helpers so we can have more control over the types. On one hand, we can make sure that only values that are mini cross-frame messages are ever sent via post message. So this function is our post message function. It only takes a mini cross-frame message, and if you pass it something else, Flow will not even build your file. On the other side, we parse post message. We take in a mix value, which can be anything, and we return a mini cross-frame message. So here you can see where we do that unsafe casting. Message at first is a mixed unknown type. We would have to refine it, but instead we just cast it to any and then cast it back to mini cross-frame message, which is the return type of our function. Now we can use our really nice switch case message handlers to handle the message because it's the right type. Here's an example of this in action. We can see that Flow knows exactly the type of the message after it goes through a parse post message. So despite what I just showed you, there's actually very few legitimate reasons to cast to any, and I generally advise enabling a linter to lint against any, especially in new projects. Take the time to get yourself used to types and used to doing things safely. But if you're working with lossy, trusted interfaces like post message or event emission generally, it might be worthwhile to use any to cast your unknown mixed types to avoid the runtime overhead of type extraction, which is what I showed you in part 1. This is going to be the last part, and this is probably the easiest part to understand, and even if you don't know anything about static typing, this might be useful for you. Number 3 has to do with all of the different browsers that we want to support. Cross-functional browser tests are notoriously slow, and we don't want to rely on folks on our team to keep all the browser quirks in their head in order to safely develop in Stripe.js. Flow helps us actually document and put safety guards around any third-party interfaces that we need to interact with. For us, that's namely the DOM, but you can consider any third-party interface, and you can document and put safety rails around them. One example of an API that we deal a lot with is window.getComputedStyle. So for those of you who are unfamiliar, window.getComputedStyle lets us access the resolved visual styles of any given DOM node. And according to MDN, getComputedStyle returns an object that contains a getPropertyValue function that takes a string and returns a string, and also a bunch of directly accessible properties. We can do a rough typing of this. So it takes a HTML element and a pseudo selector and returns an object with getPropertyValue and accessible string keys. However, we quickly learned after releasing our code that there's actually a non-standard case in Gecko, which is Firefox, where getComputedStyle sometimes returns null, but only in very specific cases inside iframes. And we have a lot of iframes. So in a world before we had Flow, we would have documented this code in line. I've written a ton of comments that look exactly like this, especially in our older code bases that don't have Flow. And we're really crossing our fingers that people actually remember to read the comment and understand the comment, and maybe that they write a cross-browser test to hit that exact edge case where the code is running. But we all know how good we are at reading docs sometimes, especially for features that we think we're familiar with. Like I thought I was familiar with getComputedStyle, but apparently not. With Flow, though, we can now type this interface. Like we did with postmessage in part 2, we will use a linter to make sure that getComputedStyle is only ever called via a helper function that we write. And this is a type-safe helper function. With this, all call sites of the function will now know that getComputedStyle may be null or undefined, and Flow will make the caller do the exhaustiveness checks before they use the result. So here you can see that the return type of getComputedStyle is a maybe type of ComputedStyle, which means it might be null or undefined. We can go even further. For example, if we like the consistency that getPropertyValue provides, which is that it takes a string and always returns a string, and we don't want people accessing random properties on the object directly, we can go ahead and define a return type so that Flow thinks the return type of getComputedStyle only contains a getPropertyValue function. With this, we're now casting away parts of third-party interfaces that we don't like or don't want our developers to use. And let's see it in action. Flow can tell us, first of all, exactly what the type of body styles is. And if we try to access a height directly on body styles, it will tell you that it can't do that. And to address the Firefox issue, Flow will now also not build our file if we don't explicitly handle the null case for getComputedStyle. So here I'm writing some code, and it will say that you can't call getComputedStyle and possibly null or undefined value. To recap the section, Flow allows us to very, very explicitly document the quirks and restrict the surface area of the interfaces that we interact with. And this is especially useful for the DOM for us because we're working in a lot of different browsers. We can do this with other third-party features too, like slow DOM APIs that you don't want your coworkers to use, or APIs that are only available in certain browsers. Again, these ways of using Flow probably aren't extremely novel. They're all built in, they're all pretty well supported, but these are indispensable to us working on Stripe.js. And there's actually a fourth item that having a static type checker really helps us with, and it's to not break. It's really important to not break. People can't accept payments if we break. So static types allows us to have much greater confidence in our code. I may have hinted at it briefly in other parts of the talk, but our team actually deploys 1 to 2 times a day to hundreds of thousands of consumers across thousands of websites, and requires a lot of developer care and testing to not break. But static type safety actually gets us most of the way there and gives us a lot of confidence in our deploys and our code correctness. So thank you for listening, everyone, and thanks so much to Gabby for organizing and having me here. I'm happy to answer any questions folks may have on Flow, Stripe, or static types generally. I've also worked with TypeScript, so I'm happy to answer questions there now or over Twitter later. Thank you.
Thank you, Michelle. Some badass questions for you. Why does Stripe hate Eastern Europe?
We're trying. We're trying to come here.
No, I just made that one up. Okay, the real badass ones. Would you recommend Flow for proof of concept type apps, or is it too much overhead for rapidly changing APIs?
So Stripe.js was written in the course of 1 month. It was rewritten from a mostly CoffeeScript code base. And I think Flow actually helped us a lot to prototype and iterate on the API, because every change you make, the Flow will tell you when you're doing something wrong or when you break the API. So as long as you have a good understanding of Flow, I think it's definitely not overkill to have it on a greenfield project.
And I use TypeScript, I'm afraid. What are the pros and cons of the developer experience for Flow and TypeScript?
Yeah, this is a kind of a holy war question. So we chose to use Flow because we also use React, and Flow's support for React is generally better. Flow is also a stronger type system than TypeScript, which means that it guarantees more correctness, but that also means that TypeScript is more developer-friendly because it's less strong, so it can do things that you wouldn't be able to do with Flow. Does that answer your question?
That answered it for me. How do you interoperate Flow with libraries written in JavaScript? Is there a type definition file like in TypeScript?
Yeah, those also exist in Flow.
Excellent. Excellent. Any questions from the floor before I let Michelle go to practice her arm wrestling for this evening? Question down here. Are there any disadvantages to using window.postMessage for inter-iframe communication?
It's, I think, the best way to post or to message between iframes. I don't know what you mean by disadvantages.
How do you have an origin parameter there?
Yes.
How do you restrict that origin dynamically?
Yeah, so for us, all of our files are hosted at js.stripe.com. So between the iframes, we just set that origin to js.stripe.com, and it will only allow post messages between those frames. We also do a check on the other end of the post message to make sure that the origin is correct. Yeah.
Ladies and gentlemen, big it up for Michelle Bowe.
Thank you.